Good day, my name is Tsebo Ramonyalioa, and I'm going to be talking about the convolution neural network. So, what is a CNN, which is stand for convolution neural network, is a type of artificial brain or neural network designed to help computers understand and recognize patterns in pictures. So we have a real world issue. Doctors may struggle with like pinpointing a specific type of complex disease or X-rays. So CNN can help by detecting disease like cancer or other abnormalities in medical images like X-rays, CT scans, or MRIs. This can also assist interns or trainers when they are being assessed to become a doctor or can assist doctors to make their job easier. So the input layer is two. So I'm going to be talking about the algorithm now, the model algorithm. So to explain it in this graph, the input layer is two. The pixel matrix is 28 by 28 by one, which is basically the black and white, which is basically the black and white ratio. And if it was RGB, it would be 32 by 32 by one. The convolutional layer has a kernel that is 5 by 5, which is a filter grid, and the max pooling reduces the feature maps by 2 by 2. The repetition of the max pooling and kernel filters reduce the matrix pixel to 4 by 4 by n2 and creating the 1D vector. So once the 1D vector is created, then the fully connected layer takes the vector feature map where each neural network is connected and makes the final decision about what the image is. Then the output layer is the final layer that uses a software max to predict the class of the input image. It should then output the images as a number two. So I'm going to be naming common applications and advantages and limitations. So common applications would be image classification, autonomous vehicles, face recognition. And the advantages would be automatic feature extraction, flexibility for 2D and 3D data, and spatial invariance. Now, the limitation is high computational costs, large data requirements, and data sensitivity. Okay, now in the CNN in the medical field, all the data sets act as the input, and once we add an image of the CT scan, it runs through the pre processing stage, which then creates the final output stage. Deep learning methods occur to analyze the feature map. This stage will reference what is what it has learned prior to the categories of the CT scan. If the CT scan is unknown, the algorithm will then commence the second stage output, and this is where the training and classification occurs. Then the algorithm will learn what type of CT scan it is, and then it will categorize it under its specific classification. Now, the key metrics of the CNN, accuracy ratio and the precision ratio, as well as the recall ratio. So, the accuracy ratio of current is a ratio of the correct prediction labels to the total number of predictions. The common usage of the accuracy formula is for classification tasks, for example, image classification. The limitation of accuracy can be misleading in case of imbalanced datasets where one class dominates the other data. So the precision ratio of correctly predicts positive observation to the total prediction positive. It is useful in cases where false positives, which incorrect positive predictions, need to be minimalized, such as disease detection. An example would be in medical diagnosis. Precision ensures that when the CNN predicts disease, it usually is correct. Now, the recall ratio of correctly predicted positive observations to all actual positives. The recall is used in scenarios where false negatives need to be minimalized, such as disease detection. And an example is in the medical imaging, where high recall ensures that most disease cases are correctly detected. Now, coming into the conclusion, the CNN is perfect for identifying the input of images such as CT scans, MRIs, and X rays to identify diseases or injuries, as it utilizes metrics that ensure the accuracy and precision of the images is correct. The multiple convolution layers help with the accuracy of the output layer. Even in CNN, is from unfamiliar with the images, it will learn about it and then categorize it under similar images of the same nature. Thank you very much.